Welcome to this week's episode of ClueCon Weekly. Joining us this week is an old friend of the RTC community and member of the Italian voice over IP community, which is big and filled with fun people. Lorenzo Miniero from the Janus and Meetecho, Janus project and a Meetecho company, or Meetecho, depending on how you like your pronunciation. Welcome, Lorenzo.
Thanks, Luca. It's really nice to be back.
Well, I mean, it's practically pointless, but I will still ask you for a short introduction about yourself, just for the three people that don't know you.
No, I'm sure there's more than that. But yeah, just in a nutshell, I'm one of the co-founders of a small company based in the south of Italy, Meetecho or Meetecho, however people want to call it. And I've been working with real-time multimedia applications for a very long time, so more than 15 years, starting from an academic background and then by pivoting to a more commercial approach when we started founding our company to work with these protocols. And so starting from standard protocols like SIP, RTP, and stuff like this, we ended up playing a lot with WebRTC, and just recently we dipped our toes into QUIC as well, just to see if there is any chance of it actually sidelining or replacing WebRTC in the distant future.
Nice. Well, I mean, I've been working with WebRTC for a long time now, and surely it's got its own set of interesting characteristics, so to say. So, well, maybe we can start from there. Like, what is QUIC? Where does it come from, and what's the goal?
Yeah, in general, and I hope I will not offend too many people with this because I'm new to QUIC myself, so I just recently started studying it. It basically started as a protocol to try and replace basically improve on what HTTP3 was in principle. So it was originally conceived by Google as a new transport protocol to improve the efficiency of HTTP, because HTTP2 was much better than HTTP 1.1, but was not good enough in some edge cases. And so the idea was to try and get rid of the head of line blocking that you typically have with TCP as a transport protocol. And so, really long story short, they came up with a way to put together TCP and UDP and try to take advantage of both, so that you have a transport protocol that goes over UDP, but there's several characteristics that make it look much more like TCP in the first place, with advanced concepts like multi-stream, which means that where in TCP you only have one stream of data where everything goes. So even though it may be separated from the application level multiplexing perspective, so you have different applications, so sharing the same TCP channel and doing something with it, it all goes over the same stream of data. So if you are still waiting for something, then everything else that came after that must wait for those packets to arrive, in a nutshell. And so QUIC tries to solve that by basically introducing the concept of multi-stream, where you still have streams pretty much as TCP, but you can have multiple streams going on in parallel at the same time on a QUIC connection, which means that you don't need to wait for a specific stream in order to receive data from another stream. You can prioritize them, and so on and so forth. And then it's basically an improvement on TCP on pretty much every aspect. First of all, because it can do real time as well, because it's based on UDP rather than, again, just taking advantage of that single stream as TCP does. It has an improved mechanism for dealing with packet loss, retransmissions, these sort of things, congestion control, basically everything that you would expect TCP to have, QUIC has as well, but it's supposed to be an improvement on all of that. And so the very first protocol that was built on top of QUIC was HTTP. So that's where HTTP3 comes from. So HTTP3 is basically a mapping of the new HTTP2 semantics on top of QUIC instead, in order to try and leverage all these new features that QUIC has in order to make it much more efficient than it was before. But then it soon turned out that you can use this new transport protocol for much more than that. And so people started experimenting with, how can I transport this existing protocol on QUIC rather than TCP? Do I get any advantage in terms of for doing that, and so on and so forth? And recently they started doing the same for real-time multimedia applications as well. So why don't we try and transport RTP over QUIC, to make a simple example? Or why don't we try to create a new ecosystem on top of QUIC that allows us to deal with media in a more flexible way. And so these are all experimentations that are going for. And if you have a look at the IETF, for instance, IETF meetings, you'll notice that there is a lot of activity on QUIC and the different protocols that can be carried on top of that.
So one thing I'm really interested in, which I'm having sort of trouble, not even trouble, but I mean, it's not super easy to understand, is how does QUIC handle packet loss when it's UDP based? Like, we all know the joke about, have you heard the joke about UDP? And then you don't say anything because you didn't get it. But
exactly.
So I'm curious, how does it work? How do you prevent packet loss in UDP only scenario?
I mean, there's no real, I mean, you cannot really prevent packet loss, but you can try and circumvent it or handle it somehow, which is the same thing that TCP does as well, because packets can be lost there as well. But then you have reliability mechanism built within the protocol to retransmit those protocols that you missed. And in this sense, QUIC works pretty much the same way, because when you send, I mentioned that UDP is sent over UDP, which means that you for each QUIC message, you basically send it on a UDP datagram. And then, which means that a QUIC packet is typically made of a header where you have some information, and then you have the actual payload, which contains the different frames that are actually part of the QUIC message exchange that you are doing. And within the header part, there is information that allows you to identify specific packets, one of them specifically being the packet number. And so each packet has its own packet number, depending, I mean, I will not go too much into the details of different encryption levels, but in general, each QUIC packet has its own packet number. And there is an explicit TAC mechanism where on a regular basis, the receiver will tell the sender which packet it did receive, and basically, and this will allow the sender to basically figure out if there is any gap in the sequence, in the packet numbers that it received. So it could be, if you are familiar with, for those familiar with the WebRTC world, it's pretty much the equivalent of the NAC that WebRTC has, but in reverse, of course, because with WebRTC, we have NACs where we say the packets that we didn't receive. Instead, with QUIC, you acknowledge all the packets that you received so that the sender has a complete view of which packets were actually received by the other party. And then applying some specific algorithms that take into account the round trip time and stuff like this, the sender can decide whether or not to retransmit some of the packets that were lost. And it will do that by resending the same packet, but with a different packet number, because of course, each packet needs to have a different packet number in that sense. And this basically allows you to create this reliable mechanism on top of UDP, because if you do miss some of those packets get lost, as a sender, you will receive an acknowledgement about all the packets that were received, and you will have enough information to decide what to do, whether or not to retransmit them or not. And there are some packets that you are supposed to always retransmit, but you can also decide to, let's say, stop sending some streams and so on, if, for instance, you realize that congestion control told you that you're sending too much.
Yeah, that's really interesting. I mean, so before we delve into the world of what it means for RTC, one flat out question: what's the support looking like? Like any protocol, the problem is going to be finding people who support it. How is the adoption going with QUIC, or is it something that any platform can do?
I think it's something that pretty much everybody can do. I mean, there's already really a lot of different libraries in different programming languages that have been around for quite some time. So some of them are really battle tested, and there's also implementations by very big companies out there. For instance, Cloudflare has its own implementation, Google has its own implementation, Microsoft the same, and so on and so forth. And so there's many implementations that can be leveraged already exactly as they are, as far as the transport protocol is concerned. And mostly because the most interesting aspect of QUIC is actually what you can do with it. Because of course, QUIC itself is a transport protocol and has its features, its pros and cons and stuff like this. But then it comes to the question whether or not you actually need those specific features, or if existing solutions actually fit what you need. But getting into QUIC is relatively easy if you start using an existing library, for instance, to do the job, as most do. I personally went a bit different way, because I tried to implement the whole of QUIC myself, mostly for, let's say, learning the protocol better, because QUIC itself is a very big specification. It's actually spread on multiple documents at the same time. And so basically just studying an existing library and basically trying to tinker with it would have worked, but it would not have given me enough knowledge about the protocol itself, because exactly as with WebRTC, you only get the best out of WebRTC if you know how the underlying protocols actually work, where the pitfalls are, where you can encounter any issues and stuff like this. And you only get that kind of knowledge when you start getting your hands dirty with these protocols. So when you start actually fighting with some of the different aspects of the protocols that you struggled a bit with. And this is why I went in the direction of trying to write my own library. But this is, of course, not something that everyone should do, also because it is a titanic endeavor. I don't even know if this is actually the library that I will stick with for the future. It is really a learning process for me right away. But I do know that there is a lot of people experimenting with QUIC for different applications. And even within the context of real-time multimedia applications, there is a lot of people experimenting with this new protocols as well. Because just last week I was at the IETF meeting, and before any IETF meeting, there's a hackathon session where people interested in the same protocols meet around the same table and try to hack things together in order to do some interop tests and stuff like this. And our table had like 10 different people with 10 different implementations, all trying to basically interact with each other one way or the other. And this is, I think, an indication of a great interest in the technology. So something that should be really on everyone's radar, because this is a protocol that will be a protagonist in the future.
Oh, well, it is really interesting from a structural standpoint. I really like the starting point of having to me, the genius, I'm an application developer, right? I live one level above this kind of thing. For me, using UDP as the base is just genius. Like it solves so many problems, actually, because you don't have to manage just the fact that every package is encrypted by itself. So you don't have to, if you don't have the start of the connection, you're not able to decrypt anything. While with UDP and QUIC, you can do that. It seems like it's very thought out. It's something that should have been done the first time.
Yeah, exactly. And I think this is actually what happened. So basically, everybody tried to learn from what the existing transport protocol taught everybody in the past 20, 30 years. So they basically tried to learn from all those lessons and try to come up to bake them into this new protocol in order to try and take advantage of all the lessons that were learned.
So when it comes to RTC and WebRTC in particular, QUIC it will be an alternative to WebRTC, right? Although WebRTC is difficult to define because, for example, the browser side of WebRTC you still need. How do you get the devices otherwise?
Yeah, no. I mean, for the moment, I see them pretty much as alternatives. So I don't see anyone replacing the other anytime soon, especially considering that, for instance, when it comes to QUIC and real-time media, there's two main efforts that are out there. So the first one is very simply RTP over QUIC, and that is simpler for us from the WebRTC world to understand, because it just means put RTP on a different transport protocol, and it's something that is relatively easy for us to understand, because RTP is our bread and butter. It's what we use every day. It's what we are using right now in this conversation. And then there is media over QUIC that tries to take a completely different approach, because in that case, they are completely ignoring the existing functionality. So they are not relying on RTP. They are not relying on the traditional real-time protocols that have been around in the IETF world. They're trying to come up with something new. So something that is still pub/sub based, so pretty much as SFUs work today. So you still have the concept of entities that are pushing data and entities that can subscribe to this data, but using a different approach that is more, let's say, generic and more flexible, because they don't even talk about audio, video, and data and so on. They just talk about objects that are being sent. And then this object can be tagged with specific IDs. You have object IDs, you have group IDs, you have subgroup IDs, all things that allow you to group some objects together. For instance, a sequence of video images starting from a keyframe and all the differences from that keyframe can be considered a group. And so all of those frames will have the same group. A new keyframe arrives, you add a new group ID, and then you start indexing them in different ways. So it basically allows you to map different media of different kind on top of these basic semantics. And then apart from this, it's just a matter of routing these objects around, but all in a concept that allows you to have, at least in the idea that they have for the media QUIC working group, some sort of a configurable latency so that you can have live conversations like the one that we're having right now, or real-time streaming, real-time broadcasting. So the typical use cases that we use WebRTC for. But at the same time, you can also build something like a traditional broadcasting, like HLS kind of thing, or even voice video on demand kind of solution on top of the very same protocol, because these objects can be cached. And since they have unique IDs, you can also say, give me the objects starting from this ID up to this ID, and these sort of things. And so they are differentiating these two use cases, all for the purpose of having a very configurable protocol that will allow you, for instance, to watch a match, for instance, a football match on TV. You go on the bathroom for a second, you go back, you miss the goal, and you say, let me go back 2 minutes because I want to see the goal that I missed. Using the same protocol primitives, you do that.
I like AC Milan, so there's no goals to watch, so no problem.
Yeah, of course. I mean, assuming you have you have a team that scores more than AC Milan, that's a valid use case, let's say. And so these are all the, let's say, the ideas that they have in mind, which I found interesting because these are, of course, things that we can do with WebRTC with some manipulation on the server side, because we can cache RTP packets, we can re-inject them somehow and stuff like this. But these are all typically implementation-specific decisions. So there is no standard way to do that. While instead, Media over QUIC is trying to address this from the protocol perspective. So it will be the protocol itself that will allow you to ask, for instance, how much time of the media in the past you want to get before you start getting the new packets at the same time, and these sort of things. And it is a let's say, flexible and dynamic protocol enough that, again, the concept of objects means that it can be used for everything. While for instance, with WebRTC, we can send audio and video packets. If we want to send data, the only way we can do this is using data channels. And of course, it's harder in that case to then associate a specific data object in the data channel to a specific video frame, for instance, to make sure that a graph that you're getting as a JSON object from data channel is applied on the right video frame, stuff like this. It's a bit harder to synchronize the media that way, while instead this is supposed to be easier with mock, because in that case you just have generic blobs of object that you can then basically use and distribute any way that you want. And then you can add some metadata in front of the different objects to basically describe them any way you want, even though there will, of course, be standard ways of describing objects as well. So something similar to what RTP is for audio and video will exist in the different forms, but in the different form on Media over QUIC as well.
Well, I think that, so I was looking at the support, the Wikipedia page, so maybe it's not precise or up to date. Looks like all main browsers and most operating systems have a few libraries to use it. There's a lot there you could really do rather quickly with QUIC. Like, it's already there. It's not something that's coming in the future.
Yeah, no, absolutely. And the main idea is that, especially if you want to use QUIC in a browser, what you typically will use are the so-called web transport. And web transport, in a nutshell, can be seen as the WebSocket equivalent of QUIC. So with HTTP, you create a WebSocket channel by doing a connection upgrade. With QUIC, the approach is similar. You do an HTTP3 connect, and you end up with a web transport. And on the top of this web transport, you can do pretty much whatever you want. And so there are standardized APIs to already create web transport within any browser, as you noticed, to actually create a session like this. And Media over QUIC is actually supposed to be usable either on raw QUIC. So if you don't need web transport, you can just use QUIC as it is and just negotiate Media over QUIC as a protocol, or use web transport as the as the application layer channel over which you send and exchange all these media over QUIC messages, which is indeed quite useful because it opens the door to all the different things that you can do within a browser right now. Because, for instance, you pointed out that with WebRTC, we need to get access to the microphone, to the webcam, and these sort of things. And these are all separate APIs from the actual JSAP-related WebRTC APIs that then turn this into an SDP. Let's exchange data. Let's use RTP to actually exchange media. Accessing a microphone and accessing a webcam work the same way, and they give you basically access to the data that you need. And so if you hook that up to web transport and stuff like this, it means that you can already use, for instance, media over QUIC within a browser and use it for something. And in fact, there are a few demos out there that do exactly that. So basic demos that use those APIs to capture webcam and microphone, then you use web codecs to encode the media, for instance, in Opus, in VP8, H.264, or whatever you want. And then these encoded media frames, you send them on top of media over QUIC somewhere. They will be received by somebody else. They will receive the data via web transport. They will use web codecs to decode this, and then they will display it in a video element or play it out loud in an audio element. So pretty much as we do with WebRTC today, just with a different transport protocol, let's say. So the use case is there. It's of course at the moment probably not as efficient in WebRTC, just because you do need to use web codecs, which is not really the same thing as having codecs that are baked in the browser itself, so much more optimized in my opinion. But
you need to use web codecs at the moment?
Yeah, if you want to use media over QUIC with the existing browser APIs, that's what you need to do, mostly because there is no hard-coded support for media over QUIC in browsers. Browsers only support QUIC and web transport, but what you send over on top of web transport is entirely up to you. So it's up to you to create a media over QUIC stack in the browser, for instance, and then access the devices and so on and so forth, which makes it much more flexible for who wants to have complete freedom in terms of creating everything the way that you want. But of course, also much more complex if you don't have access to existing libraries to do the job, because with WebRTC, you just use some APIs and encoding, and the WebRTC protocol is all done for you. It's much easier to use, but it's also more constraining in terms of what it allows you to do with respect to a protocol like media over QUIC, which is why there is this interesting trade-off at the moment. And also the reason why I think they will coexist for a long time, because WebRTC works very well for a lot of use cases, and it will take time for media over QUIC to actually erode this usage. So there will be people that will jump on the media over QUIC wagon as soon as possible because they are interested in the flexibility, and there will be others that will wait because it will not be as easy to jump from one technology to the other, let's say. I experimented a bit with this because I actually implemented a media over QUIC to WebRTC translator within Janus as a proof of concept. And so that allowed me, for instance, to have a user using the meta implementation of media over QUIC, which is a web page that uses web transport and web codecs to implement media over QUIC. I can publish media there, and I can receive it via WebRTC through Janus. And at the same time, I can send WebRTC video and audio via Janus and receive it as media over QUIC objects from a media over QUIC subscriber. So I did this as a proof of concept using some of the assumptions that these implementations use, and it was possible. But of course, this will require some work before it's actually usable.
Yeah, I think there's a lot there. It's still to digest, like the fact internet codecs. It's maybe a bit too low level for me right now. Probably have to wait for a while. So how's the Janus support doing? Does Janus support QUIC?
No, I mean, what I'm doing right now is basically, sorry, I'm basically writing a new QUIC library. So I'm writing everything related to QUIC in a separate library, and within this library, I'm baking support, integrated support for these couple of protocols that I mentioned. So I added APIs to use RTP over QUIC according to the latest specifications. I added some APIs to create media over QUIC sessions, and so the ability to send and receive objects, subscribe stuff, and stuff like this. And so I'm creating this as a completely independent project that is usable by anybody that wants to implement these protocols. And I started implementing this as a library exactly because I'd like then Janus to use this library as a dependency for anything that is QUIC related. Because to make a simple example, the easiest thing I could do is, for instance, add this QUIC library to allow people to control Janus. You can control Janus right now, for instance, using REST calls or WebSocket, but why not Web Transport as well? Because Web Transport is equivalent to WebSocket. So this could be an easy way to start, where you add a new plugin to Janus that allows you to use the Janus API on top of Web Transport. My library would be used for that because my library supports Web Transport. And this way I can send and receive API messages on top of QUIC, basically, and start already using QUIC for that, which of course would not involve media in this case, but it would be already a way of using QUIC in a flexible way. Then for the RTP over QUIC support, I could integrate this in different things because, for instance, we have RTP forwarders that allow me to, each WebRTC session that I receive, I can forward to a separate UDP endpoint for doing some manipulations. So for instance, external recording or sending it to a transcription engine or whatever. And rather than just using plain RTP over UDP, I could support RTP over QUIC there as well. So that I can have, for instance, two different Janus instances connected via an RTP over QUIC channel, and I could multiplex multiple sessions over there and exchange media that way. You could act, let's say, as a sort of media trunk between two different sessions, which could be an interesting opportunity. And of course, the media over QUIC functionality is also something that could be interesting, even though a bit harder to implement the right way, because as I mentioned, media over QUIC is supposed to be very flexible, and but in also basically also allowing me to bridge, for instance, a WebRTC SFU to an SFU that is based on mock instead is something that could be interesting, because it would allow people to have both technologies at the same time. So starting to experiment with both technologies at the same time without losing everything that they have right now. So no need for a hard switch from one technology onto the other. You do have both for a little time, and then you can slowly adapt from one to the other or keep both and stuff like this. So pretty much as it happened, if you think about it, when WebRTC came out and a lot of people were there with huge SIP deployments, of course, not everybody just threw away all the SIP infrastructure they had. They basically just started putting WebRTC in front of it or started integrating WebRTC as part of their SIP infrastructures. And this is still very much what's happening today. So WebRTC came out 10 years ago, and SIP is still very much strong and very much used, and they are actually used together for many things, which is what I expect will happen also with these technologies at the same time. So I don't expect a hard replacement apart from some very specific use cases.
And so how long do you think is going to take before the industry pretty much has this everywhere? Because it's so interesting, I want to use it.
I think it will take still a few years, probably not as many as WebRTC took. I mean, for WebRTC to be a stable release, because of course we both started using WebRTC as soon as it came out, and of course there were some hiccups here and there. Maybe a browser update would break everything and stuff like this, but it soon started to be pretty much reliable for most use cases. So it just recently became a frozen specification, a stable specification, and so on that everybody implements. But it took about 10 years before it could actually be something that we can call a stable specification, let's say. And media over QUIC has only been around for maybe a couple of years. So there's still a lot of things changing, because I started looking into it this summer, and there have been, since then, I think, five different drafts that have been published with big changes in the middle. So I expect that things will change a lot. There are still changes that are happening a lot in there as well. But you see very big companies investing in this, both from the real-time world and from the CDN world, because you have Cisco is very, very interested in that. Google is very interested in that, but Akamai is very interested in that. Meta is very interested in that. So you see these huge companies investing a lot of efforts in these technologies, which means that they will make use of it for sure. So they would not basically spend so many cycles on that otherwise. So even if people don't want to jump on it right away, I think it's still a good idea to follow a bit how the specification goes, what it means in terms of use cases, the different things that you can make, and so on and so forth. Which is why, for instance, I wrote very long posts, probably too long blog posts on all of these subjects, because I started this summer as basically dev blogs also for myself. I started writing my experience with writing the basics of a QUIC stack, and then I explained, now that I have a QUIC stack, how can I do RTP over QUIC? And then once I understood better how RTP over QUIC worked, I moved to Meetecho over QUIC, which was a complete shift in perspective. And so I think that even just reading those blog posts should give people an idea about the direction that this is going into. So, I mean, and I wrote this just a couple of months ago, and on some aspects they are already a bit outdated, just to showcase how fast they are moving in some aspects. But in general, yeah, I guess that keeping up to date with these new technologies is a very good idea. Just not to be surprised when it will, for instance, make a big bang and a lot of people will start using it.
Yeah, I don't look forward to having to go through. I remember 10 years ago when you had to download the latest Canary Chrome, try it out, make sure everything still worked, and would wake up to emails from the various newsletters, thinks, "Oh, this API is broken. Let's go fix it." And you had like an
this
hour
is one
before
of the things where, in theory, QUIC should help, because one interesting aspect of QUIC compared to TCP and UDP, for instance, is that QUIC itself, since it is built on top of QUIC, is a transport protocol, but is a transport protocol that lives at the user level, at the application level, which means that, for instance, you don't need to wait for a kernel update to have a quick update. So you can just, for instance, pull the library, the latest updates from the library that you're using, and basically things will start working. And same thing for these protocols over here. So since from the browser, the only thing that you need is a web transport availability. As long as web transport is there, and web transport will not change much once it's published, the only thing that you need to make sure is that your Meetecho over QUIC stack is up to date. And typically, most companies will write their own Meetecho over QUIC stack in JavaScript, for instance, which means that it will be easy for them to update that part if they notice any problems and so on. They will have more control over the stack at both on the server and the client side. So they will not need to wait for Chrome to fix a bug in WebRTC or to add support for a new codec, this stuff like this, because basically everything will live at the user application level, which means that you will have more control over all the aspects, which again is a pro if you think about the control aspects of it and the ability to update quickly and these sort of things. And it's a con at the same time, because it makes everything complex if you're writing everything yourself, and you have to take care of many different aspects that, as of now, WebRTC is taking care of us for free, basically.
Right. Well, I mean, I'm really looking forward to getting to work on this. I'm going to take a look and see if I can implement something. Web transport should be relatively easy. I think the main change, and coming from the application developer side, the main thing is going to be having native codecs in the browser. That's probably going to be the make or break for me as a developer. Like I need that before I can work at that seriously, just because I need the ability to truly move media around.
Yeah, and this is what web codecs are trying to address. So, and web codecs is, of course, a standard API. So basically, how it is implemented, it can be implemented different ways, but it has standard APIs. I don't know, for instance, if they have ways to support hardware codecs already, or if this is a no-go. But in general, since this is all based on WebAssembly, this is all still rooted in, for instance, C code or Rust code or something like this. So I think that over time, this will improve. So the only thing that all the WebRTC guys like us need to basically dive into is figure out how to take advantage and use web codecs efficiently, which is something that I personally haven't tackled yet. So for the moment, I've only looked at the protocol aspects of everything. So for anything that is related to the client side of it. So getting access to the media, encoding it and stuff like this, I've basically relied on existing demos to make things easier, because it's still way beyond my area of expertise, because I'm not a web developer myself. So I am not really that familiar with WebAssembly, web codecs, these sort of things. So I will probably start using existing things and play with those a bit. But as an engineer, I'm much more interested in the protocol aspects of it. So how media over QUIC works under the curtains, these sort of things.
Well, again, it's going to be very interesting, and feel like there's a lot of very, very smart decisions around QUIC. So looking forward to not having to do some of the to jump around some of the obstacles that we currently do as soon as there's good support in the. Well, last thing, are you speaking at any conference soon? Are you looking for any papers for anything?
Yeah, no, I think that the next one will probably be FOSDEM, because we briefly chatted about this before we went on the air. But FOSDEM is indeed coming back the 1st and the 2nd of February of next year. And the call for paper for the real-time working group, the real-time dev room, is open. It will be open until the end of the month, I think. So if anybody has proposals for that, we are very open to discuss them. And I think I will probably submit something about these efforts that I've been working on. Hopefully, I'll be able to release the library that I was still talking about. So this QUIC library that I mentioned, I do plan to make it available as open source, but there are still some issues here and there that I want to tackle before I actually open it to the world and people start playing with it. So hopefully, FOSDEM will be the opportunity to actually present it to everybody, so that people can play a bit with this in a more proactive way. But yeah, FOSDEM is probably next, and then we'll see what happens in the next few months about other events.
Nice. Okay. This year I'm finally making it to FOSDEM. Those dates are clear, so I'm certainly coming. So if not as a speaker, I really want to come and meet the community again. So it's really just, it's my second favorite conference after ClueCon.
Yeah, no, I'm definitely looking forward to it, and to catch up with you in person again.
Well, then, Lorenzo, thank you very much for joining us today. It was a great chat. We went through QUIC, some updates and what's going on. And, well, looking forward to seeing what you up next. And, well, thank you for now.
Thank you for having me. It was great.
Rest of the people, I'll see you next week. Bye.